Hello, everyone, and welcome. My name is Eric Franzen, President of SemanticWeb.com. We would like to thank you for joining us today for this webinar, a joint production between Dataversity and SemanticWeb.com, with our speaker, Gerald Bernand of Intent. Today, Gerald will be discussing monetizing content with semantic technologies. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. However, we do want to hear from you. For questions, we will be collecting them via the Q&A box in the bottom right-hand corner of your screen. Or if you like to tweet, we encourage you to share highlights or questions via Twitter using the hashtag SemanticWeb. As always, we will send a follow-up email within 2 business days containing links to the slides, the recording of this session, and additional information requested throughout the webinar. With all of that, please allow me to introduce you to our speaker for today, Gerald Bernand. Gerald is the Chief Technology Officer at Intent. Intent is a search technology company that leverages its proprietary services to deliver more valuable results for advertisers, publishers, and consumers across targeted vertical industries. Gerald has over 25 years of experience in the domain of computer science, with an emphasis on semantic search technologies for the past 10 years. Previously, he delivered complete solutions for an auction house and a private bank in Switzerland. And while there, he worked on projects ranging from video analysis and video broadcasting platforms to enterprise search and a web-scale search engine. Gerald holds a degree in computer science, management, and finance from the University of Geneva in Switzerland. So quite a good background with a lot of relevant background for today's topic. With that glowing bio, I will give the floor to Gerald to introduce today's webinar. Hello, Gerald, and welcome.
Good morning. Thank you, Eric, for this introduction. I'm very excited to share over the next 45 minutes what we do at Intent. I'm happy to see that there is such a large attendance today. It shows 3 different things to me. The first one is that monetization is an ongoing challenge for online properties and publishers, and they're always looking for a better way to approach that and monetize their content. Similarly, relevance is an issue that is present in the mind of most advertisers and publishers alike. So everything that has to do with more relevant ads and more relevant advertisement strikes a chord with a lot of people. Finally, it also shows that semantic as a buzzword is alive and well. Let me just get to the next slide. So here we go. Sorry about that. The mouse was not cooperating. So the word semantics is defined as related to meaning or logic, and it's pretty easy for any product to claim that they have some semantics in it. And that in turn creates confusion on the market because everything seems to be semantic or have semantic magic in it. At Intent, we're primarily a search company, and what I will show you today is what we mean by semantic and how our technology leverages that. I hope that this will allow you to see other products in a different light and also evaluate other technologies that are on the market in a new way and be maybe more critical about semantic products and be able to evaluate with a little bit more discrimination what they mean. So what we will do today is first look at the traditional campaign management and the various challenges that are related to paid search advertising. I will present how some of the semantic approaches that we use at Intent can help improve the quality of the campaigns on the advertiser side with reduced amount of work, and also more relevancy, which is a benefit both to the publisher and the advertiser. because the publisher, if the content is aligned with the ads, there is a coherence on the page that is achieved that gives readers a better feel about the site. And we will look then at what it takes on our side at Intent to manage this large semantic indexing engine. And then I'll finish with a couple screenshots that show those technologies in action in some other of the products that we provide. So starting with the campaign management, this is must be very traditional representation of how the advertiser tries to reach the consumer. The goal for the advertiser is to try to sell product or service and get in exchange for money, obviously. And to do so, the advertiser needs to go through either agencies or directly through ad networks, interact with publishers in order to reach the consumer. To do so, the advertiser needs to often spend money on their side, whether it's campaign management or keyword selection and things like that. We'll get back to that in a minute. Or they can pay agencies to do that for them. They will also spend money with the ad network during the campaign as they run the campaign to pay for the clicks that occur. That can be quite expensive, and there's a flurry of tools that have come over time to try to help the advertiser in managing the campaign better. Let's look at the advertiser and the agency, which basically do similar job, just at different scale. So the naive ideal perspective from the advertiser or from an agency is you want to create a new campaign, you want to do all the creative aspect of the ads, write the ads, prepare the landing page that's going to be associated with the ad, make sure it's tuned properly, set up the conversion tracking, and then fund the campaign, and you're ready to go. Unfortunately, it's not that simple. Oftentimes, you get faced with setting up an optimized keyword campaign, and this in turn forces you to become an expert at keyword selection. You need to be familiar with the notions of negative keywords, quality score, broad matching, long tail, etc. And finally, you need to maybe acquire tools to help in the process, because those things are not trivial and they take a lot of time. And worst of all, you need to repeat this again and again on an ongoing basis throughout the lifetime of your campaign. You need to adjust things. A couple other issues that you find with keyword selections, I will talk about just 3 of those today that advertisers typically find themselves faced with. The first one is how you select keywords. Do you want to target affordable popular queries, which are affordable, but there are so many of them that oftentimes they're not precise enough to capture what you're trying to sell? Or should you target expensive specific queries? And those expensive queries are much more specific, but they're going to cost you a lot more money. Or do you need to target large volume, cheaper long tail queries? And those queries are much more diverse, and they will cost less just because they're less well identified as key queries to try to reach your audience. And the question you always have is, am I forgetting any keywords that would be relevant to reach my target audience? The other point is that you cannot guarantee that those keywords will improve your campaign performance. And Google and other companies make sure that it's very clear that even though they provide tools for you, they cannot guarantee anything about whether those keywords will improve your campaign or not. So you're really on your own. The second aspect I wanted to talk about is the ambiguity of words. When there is an article that talks about Windows, how clear is it for you or for the machine that tries to do the matching that it's talking about a window you can open versus an operating system? Likewise, when an article talks about Apple, how clear is it that it's talking about a brand or a type of fruit? And that can create a lot of problems for the advertiser, who needs to make sure that he selects his keywords in a way that is precise enough that he's not going to fall into the trap of being shown in irrelevant pages. The third aspect is to make sure that you can filter out unwanted articles. The two articles you have here, side by side, both contain the keyword camera and the keyword killing. On the left side, it talks about Sony making a killing against Canon and Nikon. On the right side, it talks about a camera that was involved during a murder trial for the killing of someone. So, two same keywords. Should you add killing to your list of negative keywords and thereby probably missing the article on the left if you were advertising for camera lenses? Or do you not put killing into the list of negative keywords and end up potentially showing your ad next to the article on the right? Those are non-trivial problems that advertisers are faced with. And those are not unique problems. There is a flurry of articles that you can find throughout the web that will talk about many of those pitfalls, many of the problems you can encounter when you try to craft your campaign. And the challenge is that those difficulties that the advertiser encounter in turn impact the publisher, because the publisher is more likely to have, in some cases, content that is less relevant just because it's a human that has provided the keywords to try to pick where his ad will be shown. So those creates a lot of problems. So in summary, traditional campaign management that you see today is not trivial. You need to select the right keyword at the right price, and note that I cannot really define what right is. It varies from case to case. You want to avoid being shown, your ads being shown next to undesirable content, and you need continuous tuning. And the worst of it is that you spend time and money on a task that a machine could do. So how can a machine help in doing those various tasks? The alternative at Intent is to use semantic technologies, and I'm going to go into more detail of how it works in a minute. But we use semantic technology to help select all the possible concepts relevant to a product and all the associated words associated with these concepts. We provide disambiguation, and providing disambiguation will make sure that we will not mix a fruit with a brand, for example, or a part of a house with an operating system. We will match relevant adverts to the articles with concepts rather than keywords, and that will help us focus, provide more both precision and recall when we try to pick relevant ads for your content. And we make sure we flag negative themes and undesirable content so that your ads don't get shown next to articles that might paint your brand in a negative way. So the benefit for the advertiser, there's no need for keyword management and no need to learn difficult keyword targeting methods or strategies. There's no steep learning curve to advertise online. You can spend more time to concentrate on creative aspects of your campaign. You can protect your brand. And on the publisher, you will get more targeted ads that are in line with the article content, and that will yield more revenue. The alignment is very important. So let's look at semantic ad matching the way we do it. Going back to basic, really, how would a human do it? If you were given with the task of picking up a set of ads that are relevant to a particular article, what would you do? First thing is you would look at the article, understand what it's about, what the main concepts are, what its theme is. You would look at all the different adverts you have available in your inventory, understand what they talk about, what kind of products they're selling, and then you would pick the adverts that have the most concepts in common or the best alignment with the topic on the article. And finally, of those adverts that you've selected, you would rank them and display them next to your article. That's exactly what the system does. What it does, the system is built on two main parts. The first part is the semantic engine, which is a system that can reason on text, and it's backed by a large ontology. We will talk about the ontology in a minute. That's a large knowledge base of facts and concepts. So what the system does is it's going to take every single advert that we have in the system, and it's going to focus both on the little adverts that get displayed to on a particular website, and also the landing page. And it's going to go and process all that content and extract the concept and use disambiguation to understand exactly what those words mean. And it's going to do that for every single article and every single advert in our system. Once we have processed all those articles and adverts and extracted the concepts that are behind them, the next step is going to be to compare them. So going back to the concept extraction, in this first example, a product about a bathtub, when we extract the concepts, we will find various concepts such as bathtub, stone like masonry, shower, etc. Likewise, when we do it for this other advert, which has to do with a faucet, we will extract concepts like bathroom faucet, kitchen faucet, and so on. Lastly, when we do it for the article, that this article is about shopping for a bathroom faucet replacement, we will extract relevant concepts like bathroom faucet, gardening supplies. The system is not perfect, and it considers that a faucet could be used in both as a bathroom element or as part of a garden supply. So the system is collecting all those concepts. Then the next step is, how is it going to pick what is the best ad for that particular article? Well, just like the human would do, it's going to start comparing them. So here's the first example. We look on the left at the article about faucet replacement. On the right side, the advert about a tub. And you can see that the lines between those two lists of concepts show you that they have a few concepts in common, such as plumbing supply or plumbing products, but there are not many of them, and their rank are not very high. When we do the same comparison between the article and the second advert, we see that there are many more concepts in common, and the concepts have higher ranks. So the relationship between those two, the affinity between those two, is much stronger than the affinity that this article had with the previous ad we saw. So in the end, the system is capable of taking all of this into account, and in the time it takes for the page to render in your browser, we're capable of picking the right ad, ranking them, and showing you the ad that is relevant to, the most relevant to the article first, and possibly some less relevant ads, but still that have to do with a bathroom and so on, shown on the page. The other aspect we had talked about was the aspect of filtering out content. So here is an article about Milosevic when this Yugoslavia dictator was died. He passed away, and he was buried in his garden next to his favorite lime tree. Let's imagine for a minute that you have an advertiser that's selling fertilizer. Is this the kind of page you want to be shown on? It's not necessarily clear. So when we look at the concepts associated with this page, we will find concepts, the ones in red here, have kind of a negative connotation: dictator, coffin, prison, war criminal. There are some others that have a rather positive connotation: head of state, husband, hero. And then there are the two concepts in black here, garden and lime tree, which might be the only two keywords you have in your keyword list, because you're selling fertilizer that's be good for line tree. When you craft your list of keywords, are you going to remember to include in your negative list things like dictator and prison and war criminal? It's very unlikely. With the technology we have, beyond understanding the concepts, the system has the ability to extrapolate that to see, well, what are the kind of themes that are present in the text. So of those concepts, the system come up with some potentially negative themes that an advertiser might want to exclude. So the system detects that there is discussion of death, some unfortunate events, and also talks about war. So it's very easy for an advertiser to decide whether or not the product he has is suitable to be displayed next to those topics. And he can very easily eliminate them without the need to have a very, very elaborate negative keyword search and strategy. This is available to all our advertisers, and it makes sense. It makes sure the advertiser is shown next to proper content, and in turn, making sure this happens makes the publisher relationship with the advertiser better, because the publisher doesn't have to worry about avoiding showing ads or anything like that. We will take care of this for them. So the fertilizer company might choose not to show their ads next to this article. In summary, the semantics processing that we do help bring relevance. We let the machine do all the tricky parts. It operates at the concept level, which avoids ambiguity, handles this ambiguation, and the facet classification that we provide to classify themes and topics is much more subtle than anything someone could achieve with negative keywords. And that relevance will improve monetization. There's no need for keyword management on the advertiser side. It integrates the brand safety, and there is no spending on additional tools. And this in turn allows the advertiser to focus on what he does best: build new campaign, write the ad, optimize the landing page, and track the conversion. And that in turn benefits the publisher, because the quality of the ads the publisher is going to see are going to be greater, because the advertiser can spend more time on the ad and not on deciding when the ad should be shown and not shown. So this concludes the first overview of the ad matching. Now, I want to take you behind the scene to show you how this is done at the core with the semantic engine. As I said before, the semantic engine is composed of two main pieces: the semantic indexer, which analyzes the text, and the ontology that supports, that provides the knowledge that allows the indexer to operate. Let's talk a little bit about the ontology first. We have a large ontology, over 500,000 concepts represented and over 2.5 million expressions. That's a very large system, and it captures ambiguity. It means that in our ontology, we will have representation both for Apple, the brand, and for Apple, the fruit, and all the things that go around it. And that will allow us to help, to give a way for the system to understand when he encounters the word Apple in text, whether that word is the fruit or whether that word is more related to the brand. We have many links between those concepts. We cover dozens of domains, as I said before. And we have also rule-based facets that track things like offensive language, unfortunate events, and so on. And those are built on top of the concepts we've extracted. The semantic indexing does a lot of things you would expect any indexer, for those familiar with search engines, any indexer to do. It parses the HTML page, it detects the language, it will tokenize and stem the words, so it will look at the base form of a particular word. It will do boilerplate detection, so we can ignore the footer, the header, and the menu bars on the side, so that they don't sway our interpretation of the page. And then it does concept identification and disambiguation, which is a key differentiator here. Then entity extraction and applies the rules on the concepts that it has extracted. So let's talk a little bit more about the concept identification and disambiguation. Here are two sentences. They both contain the word king. The one on the left, I defeated the king with a rook. The one on the right, I won the king with an ace. I'm sure that at this point, all of you have a clear picture of, on the left side, things that have to do with chess. On the right side, the word king has to do with a playing card. So how can the system detect the nuance between those two and pick the right interpretation for the word king? What the system has in the ontology is a representation of both concepts, king as a chess piece and king as a face card. You can see here a very small portion of the ontology. As you go down, you can see that the words are more and more generic, or the concepts are more and more generic. On the left, you say a king is a chess piece is a chess equipment is part of a game equipment. Likewise, on the right side, king, the card, is a face card. A face card is a playing card, and a playing card is both a paper product and some game equipment, and so on. So because the system has those two interpretations, he can now look at each sentence in the light of what he knows. So let's look at the first sentence, I defeated the king with a rook. You can see in this UI, which is a screenshot of one of the debugging tools that we use. On the left side, you can see vertically the keywords, I defeated the king with a rook. And on the right side is various interpretations. The codes in blue are basically unique concept codes that we use in our system. When we refer to concepts, we cannot use a human word, so we end up using those codes because those codes are language independent. You can see in yellow the concepts that the system has recognized are the most probable interpretation of that particular word. So you can see, for example, the word defeated is interpreted as losing in the context of a competitive outcome. And you can see that king in this case, we have many different kings. The two on top is king as a chess piece and king as a face card. The system saw a slight benefit, or it was a little more certain that king in that context was a chess piece, but he could not absolutely exclude the fact that it could be a face card. So you can see that both of them are highlighted in yellow. The key points here are the fact that the system is not absolutely perfect, and the system is statistically based. So he's going to make decisions based on what he knows about probabilities and about the knowledge that has been input into his system. But you can note that the king as a chess piece, he's a lot more comfortable with a rank of 59 versus king as a face card with a rank of 8, which is 6 or 7 times smaller. So he is still much more confident that it's king as a chess piece, but he could not totally exclude the fact that it was king as a face card. And then he recognized correctly at the bottom rook as a chess piece, and that was a critical element to help him pick which of the interpretation of the word king in that particular context. If we look at the other sentence, I won the king with an ace, you can see a similar situation. And in this case, he still picked both as possible interpretation, but this time the face card, king as a face card, wins by a factor almost 2 over the chess piece. And what he uses is the relationship that you see in the diagram in the middle. He knows that king is a face card, he knows that ace is a playing card, and he sees that there is some relation between them. And this activation of concept, the fact that those concepts are closely related, helps the system decide which interpretation to give to the word king. So this is the act of disambiguating a particular text, and the system does that constantly in a matter of milliseconds. Now, we'll look a little bit at what it takes to provide knowledge to the system so that it's capable of reasoning on text and producing those interpretations that we just saw. Our ontology is source controlled. We track every single change that goes in, who did what. So that's a big element, because not all changes that we do are always perfect. Sometimes people make mistakes, and the ability for us to track back who did what when is a key to being able to fix any issue very quickly. We have tools to edit and visualize the ontology. I'll show you a couple of examples in a minute. We have consistency checks against the system, which allows us to make sure that if there is any issue, we can detect them very quickly. We have regression tests. And we have Trek-like tests which control the quality of our search or the quality of the matching on an ongoing basis. So let's quickly see what type of information we store in the ontology. So this is an example for the word faucet, going back to the first example we had before with the bathtub and the faucet. So what we know about faucet is we have the different words that are used to refer to a faucet: tap, big cock, robinet in French, grifo in Spanish, and so on. You can see the languages here, which, by the way, shows that our system is supporting multiple languages, but we're just going to focus on English today. We also collect a lot of statistics about how those different words get used in the text that we analyze, and how often, for example, the word tap is interpreted as a faucet versus being interpreted as maybe a spinal tap, surgical procedure, and so on. This is another view, graphic view of faucet with its nearest neighbors and different type of relation. What I want to illustrate here is the fact that there is a large variety of relationship between the concepts, from a faucet being a part of or a faucet part being part of a faucet, to having keys and other homonyms, which are other concepts that use the same word but in a different meaning. We'll see those again in a minute. This is another presentation which shows faucets, how faucet relates to all the more generic concepts in the ontology. We know that faucet is a garden tool, that's on the very right. We know that faucet is a kitchen or bath product, that's in the middle. We know also that faucet is a plumbing fixture, and so on. You can see, again, from top to bottom, we go to more and more generic interpretations or generic meanings of concepts and how they tie with one another. And we have half a million concepts that are tied together in this intricate graph of relationship. This is another presentation about the more specific and more generic. We see bathroom faucet, waterless faucet, single hole faucet, and so on. Those are all kinds of faucets that the system is aware of. We know that tap may also be used to refer to a Trans-Alaska pipeline system, that tap may be referred to as a type of dance, and so on. We know faucet parts. We know what kind of situation a faucet may play a role in, and so on. While I was setting up those slides, I went to the concept for faucet, and you see here one of the tools that we use to pinpoint edit particular concepts. And when I went there, the system brought to my attention that there were two words in this associated with this concept that started with an uppercase letter, bibcock and tap, but they did not appear to be a proper noun, like say Brad Pitt or Angelina Jolie. You would expect those to start with an uppercase, but in this case, the system was brought to my attention that they had an uppercase letter, but they didn't seem to be a proper noun. And sure enough, if you look down here, you see BibCog has a uppercase. So I clicked the edit button. I went to adjust BibCog and tap to put a lowercase because that's what they were meant to be. Click the save button. The system said, there's no more problem. This is the list of changes you've done. And all I had to do is basically commit the change to our source control system to save this change and make it available to our evaluation and then eventually go to production. So what I want to illustrate here is how simple it is for any contributor in our company, whenever we see a problem, to go and adjust the problem. This was a fairly simple problem, so I felt comfortable doing it. Some other more complex problems that involve organizing concepts will involve linguists and ontologists, which have specialty of knowing how to represent knowledge and how to build those kinds of representations in the proper way. So, but it's very easy for us to go and edit concepts or add concepts to the system. When we talk about tracking quality, we have daily checks of the quality of the system. This is about a year old, and it was, I'll just add a line for clarity here, but basically this is the evolution of the quality for the system over a certain period. This is not in production, mind you. We have built every night that run a whole flurry of tests and provide those visual evaluations so that we can track if anything was done that would affect negatively the quality, we can go and fix it immediately. So in this case, on August 31st, either someone with the ontology or someone with the code did a change that affected negatively the quality of the system. He detected it the next day, investigated, and a couple days later applied a fix to bring the quality of the ontology or the quality of the system back on to a par. So this is an example of how we can track the quality on an ongoing basis and make sure that as we provide changes and enhancements, we don't affect negatively the quality, and if we do, we can go after those and fix any mistake that we do. So I hope with this second section that I've given you a sense of that we have a large ontology with a deep coverage of dozens of domains, that we're capable of providing continuous improvements, and we have good visualization tool and quality and consistency assessments that allow us to keep the quality high. But best of all is that every single improvement we provide to the system will benefit both advertisers and publishers by understanding what an advert, the concepts in an advert and the concepts in an article, and doing it better and better. We improve the experience of every single visitor by making sure we provide adverts that are relevant to the content that they see. We'll finish with just 3 slides that show some other applications where we have our semantic technology in action. I will start with the adverts. So those are screenshots taken straight from some of our partner publisher websites. We have many different formats of adverts, from the traditional text plus image to those which put an emphasis more on the image. They can be placed obviously anywhere on the page and skimmed to fit the presentation of your website. We have people to help you with that when needed. But behind the scene, it's always the same semantic engine that picks relevant ads to show next to your content. The second one is our video recommendation engine, which is part of a broader effort to provide content recommendation. So the same way we have the ability to pick ads, we can pick any type of media assets and pick the relevant ones to show next to a particular article. In this example from recipe.com, we can pick up automatically videos that are relevant to the recipe the person is currently watching, and then it's one click away from seeing how to prepare that particular recipe or some other related recipes. Again, the way we do that is by understanding what's on the page, understanding the salient concepts, the main concepts on the page, and using those to search for good matches into a database of multimedia assets, whether it's videos, images, or documents. And finally, we have a foot in the browser. We have a foot also in mobile. We have various applications that allow you to bring your content to the viewers, whether they are in application, a specific application that you deploy as a publisher, or as a mobile browser, or on their website, either as plugins or to work with the publisher to embed the widget directly into the publisher's page. So with this, I will wrap up and give the hand back to Eric for the wrap up and answer any questions.
Great. Well, thank you so much, Gerald. Very interesting presentation. We've gotten quite a few questions. For those listening, please do feel free to keep asking those in that Q&A box. But let's go ahead and jump right in. The first one is a question about the audience that's actually viewing these ads. The person asking says, I don't see a role for identified audiences in this process. How are they considered since they play such a large role overall? Or is that considered to be part of putting together the article?
No, that's a very good question. So the topic of this particular presentation, we focused on matching the concept. So there are several tiers in our system, and the one I talked about today was about understanding text and picking ads that are relevant to the article. We have other services above this tier that then consider the collection of ads that are semantically relevant and apply many other algorithms, traditional ones like geolocalization, things that have to do with tuning based on performance and things like that. We do not today, I believe, do anything that has to do with behavioral, but that is something we can add at any time. We've not seen the need to do behavioral at this time.
Okay. A very specific question, which RDF database are you using, if you care to answer that? And then the second question from that same person is your system agnostic to the ontology? I assume they mean by that, okay. Could you fold in additional ontologies?
Sure. So we parse RDF out of web content, whether it's microdata or microformat. We do not have RDF database with us at this point. The whole search engine is proprietary technology, and we don't use any third-party RDF repository. That is something that we anticipate will come in the future to support other types of interactions with the user, but it's too early to talk about that. The second question about agnostic to the ontology, if I understand the question properly, we constantly extend our ontology to add new, what we refer to as verticals or specific topical areas, whether it's, say, scuba diving or some other topic. So the system doesn't have to be changed when we add a new topic like that. we teach new knowledge to the system via the ontology, and the semantic engine is capable of picking up that knowledge and using it during its interpretation phase or text analysis phase. We have a proprietary representation for the ontology, and but we have in the past imported various taxonomies, open source or licensed taxonomies, in order to cover specific areas that we felt were insufficiently covered. I hope
so
that
you primarily use you primarily use your proprietary ontology, but at times you do reference external vocabularies, ontologies.
We have integrated in this ontology is about 20 or 25 years of care. In the very beginning, we used to integrate various third-party ontologies such as WordNet or NASA or some others that were available because we were trying to achieve breadth. In doing so, we had a couple challenges which had to do with removing duplication. When you import various ontologies or various taxonomies, at the top level, they oftentimes will cover the same types of concepts. A concept like airplane or car or vehicle. So you need to make sure that you don't leave multiple instances of those into your ontology, and that there is only one concept in the ontology that represents, say, car, for example. There was a fair amount of work to clean that up front. And at this point, we have other ways to integrate knowledge from existing open resources, for example, Freebase or DBpedia. Those are semi-automated ingestion mechanisms that we have. We don't really take a full third-party ontology or taxonomy and plug it in nowadays.
You may have just started to answer the next question, which is, what is the process of increasing the number of concepts in your system, and how do you curate those concepts and content?
Okay. So there are four main ways we add knowledge. The first one would be pinpoint. 3 months ago, ISIS was terrorist organization, depending on your alignment. So as things appear in news, are represented in the ontology and really urgent.
Gerald, the quality of your phone line has gone very poor just now.
How is it now?
Better. Yes.
Better? Okay. So let me rephrase. So the first process is for new concepts. We add new concepts. We monitor the emergence of new concepts in the news, and we add those concepts to the system. That's a fairly manual process. The second process is we identified areas that we need to update. For example, video games with the video game genres and publishers, and we find sources that are available and we integrate those sources. And that can be from free sources like I mentioned before, DBpedia. We have a way to map relationships and relations that are described in DBpedia, which is for those who are not familiar with DBpedia, it's a version of Wikipedia which is in a format that is more easily programmatically workable. Basically, it has a set of RDF assertions, and you can then take the facts, those assertions that are interesting to you, map them to the ontology, and then add the knowledge. So that's our favored approach right now, because it allows us very easily to collect thousands or tens of thousands of concepts, oftentimes entities, so the name of people or the name of products or things like that around a particular theme. And the second part of the question was how we curate that. The diagram that I showed you that monitors search quality is one of the higher level means for us to measure it. We have examples for many concepts. We associate a sample sentence or several example sentences for each concept. Once we have those, we have the ability to perform a regression test, and this regression test helps us verify that the system is interpreting a particular concept the right way.
And are the search engine quality score features integrated in some fashion specifically with this approach?
This approach meaning ad matching?
Well, the search engines provide quality scores. And the question is, are you integrating those in some fashion with your approach, since they have such a large role in the costs of displaying advertisements?
Okay. I'm still not sure I understood the question properly. So our search engine has intrinsic ranking abilities, and it can rank documents for their quality, independent from any query or anything that it wants to compare it with. And it has also relevancy ranking, which basically compares, evaluates the quality of a document in light of a particular other query, whether that query is actually a query someone typed in, or you could consider a whole article as a query, and the adverts that we try to pick up as search results for that query, which is embodied by the entire document.
Okay. The next question here, if that questioner has a follow-up, please feel free to submit it. The next question is, did you create your ontology originally entirely from scratch, or start with some existing knowledge graphs?
So I think we covered that a little bit before. At the inception, we used a number of third-party taxonomies, such as WordNet or NASA, or there is a MESH, is a large medical one, and we had to put them together, and then we had to develop lateral links, because those taxonomies oftentimes have just the notion of this particular thing is a kind of this other particular thing. A cat is a feline is a mammal is an animal is a living being. It has generally that kind of relationship, but it doesn't have relationships like a tire is part of a car. A car is a terrestrial vehicle and or can drive on the road and so on. So we added many lateral links, many links that relate concepts with one another, not in terms of what they are, but in terms of how they interact with one another. For example, we know that Steven Spielberg is the director of the movie Munich. We know that Bill Gates is an ex-CEO of the company Microsoft. So those are other kinds of links that help us reason on text and relate things with one another, just like a human would do.
Sure. A question here about how you manage video search. Do you convert video to text first and then semantically index the content?
So the videos we have are videos of partner publishers, and they come with a list of metadata. So we use the metadata. We still need to disambiguate the meaning of those various metadata. So if someone has a video on I don't know, on chicken, we want to know that they talk about the meat and not the animal, because you don't want to see a bunch of chicken in chicken coop if someone is looking at an article about I don't know, chicken soup, for example. So we still do this ambiguation, and that's the key to the relevancy we provide. But we use metadata. We focus primarily on textual data.
Okay. We have time for one more question, and we have one more question. So I think we've gotten to them all here. Could you please explain more about facets and how rule-based facets track offensive language?
Okay. Oh, that's I don't think we'll have time for that. Let me try to.
No, probably not. But you could probably dip your toe in the water a bit, maybe.
We build things as a pyramid. So you start with words. We extract concepts which are non-ambiguous. We extract the concepts out of the words, and then we have two flavors of facets today. We have facets that are using machine learning and something called naive Bayes classifier, for those who have any idea what it means. It's a way to basically learn to classify things based on examples. So you provide a large set of examples of good and bad. Let's say you wanted to distinguish between documents that have to do with that put smoking in a good light and those that put the smoking in a bad light. So you would not want to necessarily, if you're Disney, you don't want to show your ads next to an advert that talks about how cool it is to smoke a cigarette in the morning just after your coffee. But if the word smoke appears in an article, that doesn't necessarily immediately disqualify that document. So the classifier is capable of we give it good and bad examples of text, and the system is capable of looking at those, seeing what words appear in the good and the bad example, and then infer, when we give it new text, say this is most probably a bad example, or this is most probably a good example. And so that's one aspect of the classifier. The second aspect, we have some other classifier where we have stricter rules, where we can say, for example, if this concept is present in the first 3 paragraphs of the document and some other condition, and one of those 3 concepts is, or 2 out of those 3 concepts are present, then we want to put this document in this particular category. We use those for things like mature filtering, where we nuance our judgment. So the word naked does not disqualify systematically a document. There are some other words that I'm not going to pronounce here that would automatically disqualify a document or mark it as this document appears to have mature content. So those facets create categories, or when we take a document, we can say this document belongs to those different categories, and then based on that, the advertiser can say, I want to exclude, I don't want my ads to be shown in documents of this category or that category. So that's how we use facets to track offensive language or to track offensive content. We have long lists. Just to be, I'll just finish here. We have long lists of keywords basically, and words that are associated with concepts, and we have an extensive section that cover offensive language or mature concepts, and the system can reason on those same way it can reason on any other concepts.
Great. Thank you. I thank you for ending on a very heady question there. You adeptly answered it. Thank you so much. Gerald Bernand, thank you for this wonderful presentation and the Q&A. I'm afraid that is all the time we have for today. Just to remind everyone, we will post the recorded webinar and slides to SemanticWeb.com within 2 business days, and I will send out a follow-up email to all of those who are on the live recording to let you know the links and other requested information. Thank you again to all of you for attending today's webinar. I hope to see you again at a future one. Our next webinar will be on Friday at this very same time, where David Booth will be discussing the Yosemite project, an application of RDF in the healthcare space. So thank you all, and please have a wonderful day.
Thank you.